My mic is working. Can I get some confirmation of my mic?
It seems to be working. We can hear you.
Okay, cool. So hello, everyone. My name is Rylan, and I'm the president of McMaster Fintech Club, and we're a club that explores the many topics of financial technology. And in today's presentation, I'm going to be the fintech lead, and I'm going to help you guys learn about some new, more familiar topics like trading, indicators, and a bit of theory on how and when you should apply these trading strategies. And I'm joined today with Bilal as well.
Yep. Hey, everyone. So I'm Bilal, as you can see right there. I'm a workshops and talks lead at McMaster Google DSC. And I'm a fourth-year software engineering and management student. Nice to meet you all.
Okay, great. So let's get started and jump into a quick summary of topics that I'll be going over in today's presentation. So this presentation will cover the theory section of this workshop, and I'll be going over the math and formulas that control the behaviors of this trading strategy. So you're going to have a better understanding of how they work before hopping into actually implementing the strategy in Python later in the workshop. And the main indicator that I'll be covering today is called MACD, and it stands for the moving average convergence / divergence theorem. Now, if you've never heard of this before, then don't worry. I'll be essentially breaking down the indicator into much simpler parts while slowly building up to the actual indicator's theory. With that being said, I will start off by explaining what a simple moving average is. Then I will use that knowledge to briefly explain what the exponential moving average is. And then we'll finally put it all together and explain our indicator of choice, which is MACD. So in this workshop, we're not only going to cover the theory, but also how to actually use this indicator to make informed decisions on whether to buy or sell. I'll be covering examples of when MACD is plotted on a graph to help us make those decisions. And then we'll finish off the theory section with an example of how MACDs can be used with other indicators to boost its effectiveness. So the first topic that we're going to jump into is the simple moving average. So the simple moving average is an extremely effective yet very basic indicator that displays, well, exactly what the name suggests, and that's the moving average of a stock's price. It's simply the average price of the stock over a given period of time. The simple moving average is based on one variable, and it's the number of time periods. And this is typically the number of days that you want to calculate the average stock price over. So for example, a 30-day simple moving average would be calculated as follows. You have to evaluate the sum of the stock at a point in time, and let's say, for example, the closing price for 30 days, and then you have to divide that value by 30. Your result is the simple moving average of a stock with a 30-day time period. Now, although the simple moving average seems basic and it's easy to calculate, it's used as a foundation for numerous trading strategies and technical indicators that are vital for making decisions on the stock market. So now that we've laid some baseline knowledge for a technical indicator, we can now move to the exponential moving average. And that just simply builds off the simple moving average with edges. So the main difference between the simple moving average and the exponential moving average is that the exponential moving average puts a lot more emphasis on the recent price actions compared to the simple moving average. So you can notice with the simple moving average that the most recent price actions, which are arguably more important prices when looking for trends in a stock, are not considered as heavily as the previous days. By using a factor which we call a smoothing factor, we can decide how heavily we want to weigh the more recent prices. The higher the smoothing factor is, the more emphasis the most recent prices have on the calculation. As seen in the formula on the slide, a common value for the smoothing choice is 2. So now that we've gone over how the exponential moving average is different from the simple moving average, we can start describing how you can actually calculate it. So the calculation for today's exponential moving average is based on two factors: the present day price as well as the previous day EMA. I'll use EMA as a shorthand for exponential moving average. So the first part is calculated by multiplying the present day value with another factor, which is the smoothing value divided by the number of days, which is the same as the time period, plus 1. And the second part of the calculation for EMA is by taking the previous day EMA and multiplying it with 1 minus that same factor that I mentioned in the first half of the calculation. So by taking the sum of these two values, you can calculate the EMA value for today. This formula is extremely powerful because it allows you to adjust how the calculation reacts to recent price changes. And experimenting with this value could lead to better results than others.
Hey, Rylan, I'm sorry to interrupt, but Sina has a question. Does EMA have an explicit, or in other words, non-recursive formula?
No, it doesn't. It's so on the left part of the slide, you can see EMA today is proportional to the EMA yesterday. So in order to calculate every EMA value that's not the first day, you need to reference the EMA value for the previous day. I hope that answered the question. Cool. So you may be wondering how the first EMA value is calculated, given that the formula references the previous day EMA value. So let's say, for example, you have a time period of 20 days, and you want to calculate the EMA value for day 1. In order to do this, you need to use the simple moving average from the previous day as the first day EMA for quote unquote yesterday's EMA. So this is pretty much the final piece of information that we need to fully explain our main technical indicator, which is MACD. We can now move on to what MACD is, how it's calculated, and how to use it to guide decisions on the stock market. So MACD is actually split up into two different lines, the MACD line as well as the signal line. The MACD line is always calculated as the difference between the 26-day EMA and the 12-day EMA. The MACD line is always paired with another line called the signal line, and the signal line is calculated as the 9-day EMA of the MACD line. So on the right shows the MACD line in blue and the signal line in orange. And there's also a histogram which graphs the difference between the MACD line and the signal line. The most important factor when looking at these two lines is when the MACD line, which is the blue line, crosses the orange signal line. The MACD line can either cross the signal line from below or above. And by using the histogram, it's clear to see which type of cross is happening. When the histogram goes from positive to negative, then the MACD line has crossed the signal line from above. And the opposite happens for when the histogram goes from negative to positive. So these patterns are extremely important when it comes to using MACD as a strategy to decide on whether to buy or sell. So now that we've gone over MACD, let's move on to an example of where the MACD line and the signal lines are plotted against a stock's price over time. So here on this slide, we have the price of Apple stock over a specific period of time. We also have the MACD line and the signal line plotted below it. And again, like the previous slide, the MACD line is in blue and the signal line is in orange. So by comparing the MACD line and the price of the stock, we can start to build a strategy to help us decide on whether to buy or sell. So if you take a look at the middle of the graph, where the MACD line crosses the signal line from below, the graph above, which is the price of the stock, actually goes up. And if you take a look shortly after, when the MACD line crosses the signal line from above, the price of the stock starts to go down. So you can see this pattern once again. In the next cross, when the MACD line crosses the signal line from below, the stock's price actually goes up, and it's indicating that you should buy. And it's pretty clear that there's a pattern to the indicator, which we can use as our strategy. So when the MACD line crosses the signal line from below, that means you should buy. And when the MACD line crosses the signal line from above, that means you should sell. So we can take a look at another graph to see where these patterns are, and the graph will explain the pattern in a more clear manner. So here we have a different graph where the MACD line and the signal line are plotted, as well as the histogram. So there's arrows labeled on the graph, and the arrows colored in green indicate when you should buy, and the arrows highlighted in red indicate when you should sell. These correspond to the MACD line crossing the signal line from below and above. One important factor about the MACD and the signal line is how fast the MACD line crosses the signal line. The speed at which the line crosses indicates as a signal of whether the market is overbought or oversold. And although these patterns for buying and selling seem fairly simple, in practice, it's actually not always going to work out nicely. And that could actually result in you losing money if you only follow solely the MACD lines. So let's move on to an example where this is actually not the best technique to use. So oftentimes we can't rely on a single indicator to guide us in buying and selling on the stock market. And our indicator that we presented today, which is MACD, is no exception to this. So in this graph on the slide, there's a stock's price, as well as the MACD line and the signal line below it. So as you can tell, the MACD line in the graph is a lot different from the previous slide. And the main difference is that this MACD line has very slow crosses, as opposed to the previous slide, where it's obvious that the MACD line is going to cross the signal line quickly. Another way to observe that this is the MACD line, that the MACD line is closely following the signal line is by seeing how close the values are at any given point in time. An example of this happening is seen on the graph, where the MACD line is seen to bounce off the signal line repeatedly. This often creates confusion for you as a trader because a cross is supposed to signal a buy or a sell, but it can be misleading as the MACD line could bounce off the signal line. Or another scenario would be the MACD line slowly crossing the signal line and slowly crossing back again. So this is one key takeaway that we want you guys to have when looking at indicators like MACD. It's actually not safe to rely on a single indicator to fully guide your decisions. And it's pretty clear from the MACD example on this slide that there are limitations to technical indicators. We can combat this by using other technical indicators to help us guide our decisions. So in this example, we are pairing MACD with another technical indicator called RSI, which stands for the Relative Strength Index. And what the RSI measures is the recent price changes, and it evaluates whether a stock is overbought or oversold. So essentially, by pairing together additional indicators, you can increase the likelihood of you making the right decision on the stock market. So that completes the theory portion of this presentation. I want to thank you guys for listening. And now we're going to move on to the practical portion of this presentation, where we're implementing this strategy in Python as well as backtesting it.
Hey, Rylan. So we have another question from Leon Y. So for RSI, if a stock moves up too fast, like for example, plus 100% in one day, that would mean overbought, right?
Right, that's correct.
And another question from Sino is ARIMA, so ARIMA, derivatives also used as an indicator?
I'm actually not sure about that one. I can get back to you after the presentation.
All right, and another one from Leon. So for more stable stocks, the RSI would be more consistent.
Yeah, that's right.
All right.
All right, thank you for that, Rylan. I'm just gonna start sharing my screen for a bit. What's this? All right. Can you guys see my screen?
Yep.
All right. All right, so the main goal of this demonstration that I'm going to be going over is to kind of show you guys why MACD isn't the best choice to just use as your only indicator to trade on, whether it's algorithmic trading like we're doing here or day trading if you want to take it that way. Mainly because this strategy is very close to just simple day trading strategies using technical indicators. So you should see in the chat at the moment the GitHub link to what I'm essentially going to be working towards. So you can, as you can see right here, what I'm working towards is building out a backtesting algorithm, and for that you would need a few different pip packages installed, and they're mentioned right here. And you should have gotten an email before too about all the packages that you need to install. So just at the moment try to make sure you have all these packages installed because the script depends on them. And if you click on this link, this is essentially the entire script that we're going to be implementing, and I'm going to be explaining step by step what we're doing in this. So you guys can have this open on different screen or different tab somewhere, so you can look at it if you want for reference, or if you mess something up in the middle. And I'm always available to also answer any questions you guys have for this. So now let's actually move on to the implementation part of it. So right here, what I kind of need you guys to do right now is make sure you have all these packages here. Just copy paste it from the GitHub, mainly because you don't really need to retype this. Just make sure you don't have this because there's no point of that. But other than that, just copy paste this and get it into your program like this, and just create a class called backtest and create an initialization function for the class. And right here you have test object. So the reason we're doing it in as a class is because it's going to allow us to do a lot of to do more rigorous testing of the algorithm. And as you can just put different stocks here, different timelines here, and see how the returns are affected. So yeah, that's the main reason we're doing it as a class. So I guess we can start this right now, unless you guys have any questions. So I'm going to be observing the chat for a little bit if you guys have anything to say. But I don't think we have anything else at the moment. All right, yeah. So let's just begin the implementation part of it. So to begin with, what you want to do is YF. So let me actually, I forgot to give you guys an explanation of what each of the packages do for us. So this Plotly package right here is going to help you graph the trading and visualize everything you need. This NumPy is a small helper functions and stuff that you need for the visualization. So these two kind of work together. And Pandas data reader is what you're going to actually use to get the data from Yahoo Finance. And this is used to just overwrite this so you can get the data without any problems. So let's go to this and let's start writing it out. So first step is you need to overwrite the Pandas data reader, and you would do this for that. And this allows you to get data from Yahoo Finance without doing any extra steps. Next up, you need a few different classes. So I mean, variables for this class or this object that you're going to be making. So let's make that. And the first one's going to be called just stock. The next one you want to call this self.start date, and it's just going to be your start date that you have. And then self.end date. So these start dates and end dates are essentially when you want to be running the algorithm, or what time frame in the past you want to be testing it. Right here, I just have 2011-11. So this is a year, month, date, and you can just do this to get your current month and date and time here. So it's going from 2011 to now, is what it's set up to right now. And you guys can do something similar or try something different. And we're going to be using that a little bit later to show you some differences. So let's go with that. So self.df. What df is the data frame, and is essentially a table of information, which I'm going to show you guys after I run this script for the first time. So what you guys want to do to actually get the data in, it's very simple to get the data. You just need to do pdr.get data Yahoo right here. And you need to do stock self.start date and self.end date. Yeah, and with that, you're able to get the data from Yahoo for whatever stock you want. Right here, it's written Amazon, but let's just make it Tesla for this demonstration. And to make sure this is actually working, you just do print self.df.get, oh no, tail. Yep. So what this does is gets you the 5 last rows of the table and also the labels for the table. So I'll just show you guys how that works right now. So let's make sure this actually works as we need it to. So reveal in File Explorer. And you guys can just type CMD here if you want to quickly get to CMD, just because I'm working on Windows. And what you're supposed to do to test this script out quickly is by 3.7 testing.py, and you guys don't necessarily need to do it like this. You can just do it Python or just Py on its own, but I have multiple versions of Python on my computer, so I have to specify the version, and mine is 3.7, so I'm just using it like this. So just do whatever command you have and then the name of the file in the right directory and just press enter, and then you should see it run. And let's make sure it runs, and it does. So you can see right here all the columns. So this is the indices of these are the indices for the stock, and they're just the dates. So this is the past 5 days, and you can see the 21st, 20th, 19, 18, and then a skip just because weekends, there is no trading being done in those days. And right here, you can see the columns being open, high, low, close, and these are the exact same in volume of the stock being sold on that day. So it just gives you aggregated data that you can use to test this. And we're really going to be using adjacent close or closed. Both are the same right here. So if you got that working, then you should be on your way to set up a few different things now. So let's keep that there. So self.df. So what you need next is the EMA 12. So since we were just talking about the EMA, I'll go back to the slides. What we're going to be trying to do is, why is it not letting me? Okay, there you go. So the MACD right here, as you can see, is a 26-day EMA minus the 12-day EMA. And that's how we get the MACD right here. So let's work towards that. So for the first step, we need to get 26-day EMA or the 12-day EMA. So let's just start with the 26-day or the 12-day EMA first. So let's go back to this. Yep. So we're getting the 12-day EMA right there. And it's self.df.ilock. And what this essentially does is you select the columns and rows from your table. And what I'm doing right here is getting all the rows. So this indicates that you get all the rows, and this indicates the column you're getting. So you're getting column number 4, and you might be wondering, what is column number 4? So let's go here and start counting. So this is column 0, 1, 2, 3, 4. So these are the exact same, so it doesn't really matter which one you use. So we're getting the JSON close right here, and there you go. You got the data you need. So this is the JSON close data, and then we're gonna get the exponential moving window right here. And since this is a period of 12, we are gonna do this, and we're gonna say adjust false, just because we don't want to make it let it do any extra things that it does. And after we get the moving window, we just need the average of that, and we just do mean. So this is the exponential moving average for a 12 period for the closing values in the data frame that you have. No questions yet? All right. So next step is just self.df. Kind of do the same thing. You can just copy paste this if you want. I'm just going to do that just because it's a bit faster. And you're going to get the 26 period EMA. Very similar, but rather than using 12 period, you're doing 26 period. And you are good with that. So now we have both the period EMAs. So let's make sure that, let's now get the main goal that we're after, being the MACD. So to just get the MACD, we create another column. So whenever we do this, we're creating a column with this name and giving it the data right here. So right here, we're creating the MACD column. So we're gonna do the 6th one. So which would be this, because whenever you add a new one, it always appends to this. So 0, 1, 2, 3, 4, 5, and then 6 would be right here, and the 7th would be right here. So this would be the 6th one, so EMA 12. So self.df.ilog, and you select the column the same way, and you say 6 minus the 7th. Self.df.ilog, and you select the 7th column right like that. And now here you'll just have the difference right there as a MACD line. So now you have the MACD line ready. Now next step is to just get the signal line, which is very similar to how we're doing it here, but rather than using the already existing adjacent close values or something, we're using the MACD line for that. So it's going to be called signal, and this is going to be 8 because this is 6, 7, 8. So we're going to put the MACD here, and this is 9 period as stated in the slides. Yeah, so the 9-day EMA of the MACD line. So that's how we get the signal line right there. So let's go back to that. Oops, sorry about that. So you get the 9-day EMA like that. Next step would be to just get the, so you want the histogram that exists there for visualization purposes and to understand why some decisions are not the best to take from this algorithm. So we're going to create something called diff-SM, and it's just the difference between the MACD line and the signal line, just because we're using that to create the, like, determine the decisions, and we can color that later in the graph. So for the sake of that, it's just the 8th and the 9th. So it's just difference of the MACD and the signal line right there, and we are good with that. So to make sure that all of this processing that we have done here actually works, let's save this file and go back to our CMD prompt. Expand this a little bit, I guess, because there's going to be a lot more data now. Probably, yep. So as you can see there, we added a bunch of new columns, as I said, EMA 12, EMA 26, the MACD right here, and the signal line, and the difference of the MACD and signal line, as you can see. So with that, we have almost everything we need to actually make the decisions, but we would need a few helper functions to proceed. And before the helper functions, even we need some data for visualization purposes. So let's get rid of this since we have gotten everything we need. Now we want to store the buy dates just so we can show them in the graph later on how they function. So we're going to create a few different class variables for this purpose. So by price, you just store whichever price you bought at and whichever price you sold at, and similarly sell date. Like that. So dot sell price. So you're just storing whatever price you bought it sold at, just so we can see on the graph like where you're buying it and where you're selling it, so you can see, oh, you sold it for a loss by just looking at it in one look, because it's going to be like you bought it at a low price and you sold it at a high price, so you obviously like that would be a gain of money, but like, yeah, you get my point. And this is essentially just what's storing all the results of the trade. So the profit percentages, the gains. So if the gain is negative, it's going to be a negative value here. It would be like negative 34, and that would be negative 34% equivalently in this. And we can use that for a lot of different things later on to display our results. So let's create some helper functions to help us process these things. So we need this function called buy stock, since we're going to be buying stock or simulating a buy order. We're just going to do it like this. Obviously, in a real market situation, you would have to worry about your order being fulfilled for the price you want and a lot of those different logistics. But for this, we're just purely looking at the strategy and seeing that if it works correctly or not. So self.buy date dot append. You're going to store the buy date right there. Self dot buy price dot append price, and there you go. That's all you need to do to place a buy order in this algorithm. And it's just like you store whichever date you bought it and the price you bought it, and that's all. That's how you buy the stock here. And similarly, there is a self.sell stock. What am I doing? Self. It's not data, it's actually date. That's a typo. Sorry about that. That makes no sense. Yep, so you're gonna have almost the same thing. So date, price. This is gonna be a bit more complicated, but relatively simple to still understand. So buy cost. And the reason you need buy cost is you want to be trying to determine what profit or loss you have, so you can store that in trade result, because whenever you're selling stock, you're finishing a trade, so you're going to store the trade result there. And for that, you're going to create a variable called gain, and that essentially is going to be 100 times price minus buy cost. Bad. Buy cost over buy cost. So with that, you have, if the buy whatever price you bought at was too high and you sold it at a loss, this would obviously be negative, and then you're going to be storing that negative return there too. So right before we do that, we're just going to do self.sell date, since we have the date we're selling at, and then append date to it, and self.sell price, and then we store the price. This is just a closing price, obviously. And then lastly, what we were calculating the gain for would be trade result, and then we store the gain there. So this is just going to hold all the trade results being positive, negative, or whatever else. So with that, we have the two helper functions set up very quickly, right? Now the actual meat of the algorithm. Any questions, guys, up till now? Am I going too fast? Any concerns? Do you append to sell price? Yeah. So right here, we append to sell price because we want to be showing each of the points. So the graph that we're going to be making, just like a small spoiler to that, is just going to have
Saying
like
that
price.
you aren't like appending to self price. You're only like
Oh,
you aren't appending.
mistake. Sorry about that.
Same thing with trade res.
Yeah. Right. Yeah, that was going to cause a mistake later on. Thank you for that. And yeah, sorry. All right, so let's do the run algorithm part. With this, it doesn't really need any like parameters to it, just because we have everything already set up with this. And once you do that, you just need to kind of run the algorithm and you're good for that. So we're going to create a few different variables called holding, false. The holding is essentially telling you if you're holding stock at the moment or not. So it being equals to false is to just show that initially you're not holding anything, you still have to buy something. Location is your numerical index, just because the data frame only has indices in the form of dates. Buy cost, or rather buying cost, we are saying is equal to -1. This kind of arbitrary, what you name it as. And then len df is just the length of your data frame, or the number of rows in your data frame. One way of doing that is I'm doing it here. df macd dot count. So for I in self dot df dot index. So what you're doing here is this is going to be the date, because all the indices are dates, as you can see right here. So it's just going to be the date with some time information and stuff, but don't need to worry about that. So this index here is just the current date. And with that, you can do a lot of different things. So let's do the current closing price of the stock to be self.df dot close. And this would get the column close, and then you specify the row by the index, which is the date, as you can see right there. Do a very similar thing for the current MACD. And yeah, you can just copy paste that if you want. And here you would just say MACD referencing this. And you do current signal. And referencing this. So with this, you have, oh, there's an extra equal sign there. But yeah, so now you have all the data needed to make a decision. So let's simulate the situation where you would want to buy the stock, right? So as stated in the algorithm, right, not there, here. Yeah, so as stated here in the algorithm, you want to buy, where is it? Yeah, so you want to buy when the MACD crosses the signal line right here. So we're going to do the exact same thing. Whenever the MACD is greater than the signal line like this, we're going to be buying. And similarly, we're going to be selling when the MACD is lower than the signal line. And we only care about the when it first transition, because that's the start of the momentum. So we want to buy at the lowest point and sell at the highest point, right when it starts turning over. So that's kind of the theory in terms of if you're already holding stock, that means you already entered the trade and you're only looking to exit it. So that's kind of why you don't just keep infinitely buying until then, because then your profit margin just gets lower, lower, lower until then. And that's not an accurate measure for the trading strategy. So let's go back to this. I mean, this, yep. So if, let's see. So if the current MACD is greater than the current signal line, or the point of the current signal line, then you have a situation of buying. So, and if you're not already holding the stock, meaning you haven't entered the trade, then at the moment you can buy stock. And how do you buy stock? You just say you're holding stock at that point. So you say holding is true. And you say buying cost equals to close. And then you simulate a buy order with this. So you do self.buy stock. And you give the date being the index I, as I already talked about here. And the price would be just buying cost, as you stated there. And that's all you need for simulating a buy order. Now, the other situation we're going to be selling it would be when the current MACD is less than the current signal line, as I showed you on the graph, kind of the opposite situation. And here, you're obviously looking for the obvious, the other situation. If you're actually holding the stock, you want to be selling it. So you're going to set holding equals to false, because you're not going to be holding any more stock because you're going to be simulating a sell order. And this would be just self.sell stock using this function, and you give it the date, the closing price because you're selling it at that, and the buying cost. That would just be the buy cost. Yep, or no, buying cost. Yep, right there you go. Yeah, so with this, you're able to just send in the buying cost that you saved here, so you can calculate the actual return. One last thing you need for this algorithm, actually not one last thing, one of the few last things that you need is the situation where you are at the very end of the execution, and so that would be indicated by len df minus 1, just because it starts at 0. So whenever you're at the second last position from the length, that means you're at the very end. And if you're still holding stock, you want to sell it, because you wouldn't get another chance to sell it, obviously, after you pass the last date. Just say holding equals to false, and do this exact same thing here, because you are selling the stock. So there you go. That's a good use of that function. And next step with this would be this location plus equals to 1. And this is just a basic index that we're choosing. So when you're in location 0, you're on the first row, and so on and so forth. Now that you've done this, one thing that we need for just visualization sake is so.df.insert. And what you're doing right here is inserting to the 11th column, or the last one after diff_sm. So you're inserting the column, and you're going to call it date. This is because we need it in the column format and not the index format, which is just an array. So we're going to do that, and we're going to set false here. And with that, no, I'm missing something here. Yep, sorry about that. What I'm missing is self.df.index. So this is just an array of all the dates that the data frame has that we got. So we're inserting the dates back into the table. All right, so we're at a pretty major point in the algorithm. Any questions about how this functions at all? Or if you're having any errors? Yeah, so location is just the index, so you can just rename it, but it's the row that you're on. So if it's location equals to 0, you're on the 0th row of the data frame or the table that you're on. That's essentially all that does. And the len df is just the total number of rows you have in the data frame or the table, whichever way you want to look at it. Does that make sense? Yeah, so you can say it's like the day of the, so day 1 would be whatever you specify here. Whatever you specify here, and then yeah, that also makes sense. Does that make sense to you guys? All right, sounds good. All right, let's move on. So with this, the run algorithm part is done. Now we move on to get results. So what we want to do is the way we evaluate the algorithm and the time period that it's running in is by checking essentially the win rate of it. So the win rate would be the amount of trades that it takes that are positive. So you make money on them. Whatever it is, 0.1%, it doesn't matter. Just anything greater than 0 as a return, you want to consider that a win. So for this, we're just gonna create a function to just show the yep, that should be good. I'll just save that, and you're gonna create a variable here just called trades1, and then it's gonna be 0 initially at least, and then the number of trades you have. That's just the length of the self dot trade res, just because this is going to be storing all the resulting trades. And now you're just going to do for I in range the number of trades. So what you're trying to do here is find out how many trades are greater than 0. So let's do that exactly. So if self dot trade res and I is greater than 0, you say trades1 is plus equals to 1. All right, so with that, you have essentially your whole win rate calculated. You just need to calculate the percent rate here. So you do 100 times trades1 over the number of trades. There you go. You get the win rate of the strategy right there. But we would want to get a little more data to just be sure of what's actually happening with the stock. So let's find out what the max return was and what day it occurs. It occurs at. So this is simple, very naive, like finding the maximum value in an array algorithm. So let's just run that right here. So self.tradeRes at 0. We're doing this and not just using max because we want to get the date also at the time. So just a little detail that we need. So max date equals to str of the self sell date. Oh, sell date at 0. So there you go. Not really that, but also yeah, you need to also calculate the average return for seeing a little bit more extra statistics. And for that, you just need to do the sum of the self.tradeRes. Yeah, you don't need to do that. And sum is just, you get the sum of all the trades and divided by the number of trades. And there you go. You get the average return like that. Then you kind of do the same type of loop right here to find the maximum. But you go from 1 because you count the 0th value right here. So you don't need to recheck it for any reason. And here, what you're trying to check if it is greater than the max return, rather. Yeah, so if it is greater, then you set max return as self.tradeRes at I, and set the max date similarly to self.selldate. There you go. So you have the max date right there too. And you are good with that. Actually, wait. This needs to be a string. So with that, you have almost everything you need. So max date and max return. Did I misspell this or something? I don't know. It's not access? How is it not access? I don't know. I feel like it's making an error, dumb error. Whatever, doesn't matter. Pretty sure I'm accessing it right here, but it doesn't detect it for some weird reason. And for actually printing out the results, I would say you just go to my algorithm right here and copy paste this exact thing, because really no point in retyping this. You can change this as you feel is necessary, but this is just for my testing purposes that I'm using it. So testing.py, yep. Yep, as it's been linked in the chat, you can see. So you just copy paste that. Let me just make sure there's nothing weird happening. Oh, the chat window's right here. Let's move that a bit. Yep. So let's check if this is working. After this works, you don't have to plot the data, but we'll do it for our learning purposes. So we're gonna uncomment these lines out and run the algorithm to see if everything's working as it's supposed to. So by 3.7, and yeah, as you can see, it started from 2011 to now, placed 113 trades, and has a win rate of 38 point, some crazy accurate position. So let's just round it quickly to reduce the decimal points to √2. And now it should be a much nicer rate of return. Yep. So you got 38.05% win rate over 113 trades. So we gained a positive return, but we genuinely just failed in the actual trading strategy and only won 38% of the trades. So if the stock wasn't going up like crazy, like it is from 2011 to now, we would have lost money, and a lot of it too. So yeah, not a very good trading strategy, as you can see there. But let's change the timeline a little bit. So from 2021 to now, and see how that changes. And yeah, as you can see, the win rate has decreased a little bit, and you place way fewer trades throughout the year, just because we're going by a day-to-day basis, and there aren't many like windows that it closes and opens on. So that's how the return is panning out for that. Any questions for that up till now? I'm gonna be working on the visualization part now, and that's gonna get a bit complicated to explain, but I wouldn't stress too much on understanding it because it's not really the focus of this. So any questions? I don't think there are any. All right. let's move on to the visualization part of it. So def create, if I cannot type, trading view, and you would just do self right here. And for this, the code is absurdly complicated because the library that I'm using is kind of like that, being Plotly. If you guys have any experience with that, so for that I would just say literally copy paste this whole function if you want, and I'll attempt to explain it, but don't worry if you don't understand it. It's not the easiest thing to understand, and the code is just very disorganized too, so don't worry too much. Testing.py, and yep, so let's paste that there. And what you're essentially doing is using a lot of the classes from Plotly right here and NumPy for a little bit of it. And with this, you're using everything. So we're using, let's try to explain a bit of it. So the names are as self-explanatory as they can get. So what we're making here is a candlestick graph, and the candlestick graph, if you go back to the slides, you can see it. Not that, yeah. So what you see right here, the green, the small green and red candlesticks, as they're called, is what is being made with that part of it. So that's what we're making with this. So that's the candlestick graph, and you just use open, high, low, close values, and there you go. You make the candlestick graph like that very simply. Okay, yeah. So the ideal scenario really depends on how fast you're getting data. So let's say you're working at the trading floor of like underneath the New York Stock Exchange, right? The absolute fastest possible data. Then you would work by second or nanosecond by nanosecond. And at that point, yeah, that's what you would use. But usually like latency wise, you can go by second, if you're paying for some crazy expensive like data service. But yeah, what I personally would trade on would be like minute by minute, just because there are some free solutions for that if you want to learn about that. But yeah, it really does depend on your data and your data source, and they tend to get pretty expensive too. Yep. All right. Let's move on a little bit. So there's EMA 12 figure. This is just graphing the EMA 12, EMA 26, your buy points, sell points, and then you combine all of these into the top graph that you're going to be having, which I'm going to show you guys in a bit. Here you're making the MACD line, the signal line, just changing the colors of it a little bit. You're using NumPy here. If you have some familiarity with NumPy, so you're just creating a column right there with that. Let me take a sip of my water. Throat is getting dry. Yeah, so color, as you can see right there, you're changing that, and you're using that for just putting it into the bottom figure, which is going to consist of your signal line, your MACD line, and the histogram that you have. And you're combining all of it like here. If you have any questions about what does x-axis range slider visible mean, you can obviously go to the Plotly documentation, which I'm going to show you in a bit. But let's try to run this and show you the graph that I made. All right. So let's show you the graph. And for that, you just run this and you're going to see it show up in your browser. And there you go. You have it right here. So there's a lot of cool features that you can play around with, like with these options and stuff. And they're right here. So that you could download the plot as a PNG, you can zoom in and stuff. So you do this, it zooms into that little bit, and then you can double click to zoom out. But let's go back to reset the axes, and there you go. So yeah, you can reset the axes and stuff. So yeah. So all these green dots that you see here, these are the buy points of the stocks. So you can see right here, you buy low, sell high, you made a profit right here, right? So you bought at the date January 5th at 7:35 and you sold it at January 29th with a 793 when it was $793, right? And you can see the exact transitions like right underneath it, and then you can just kind of trace it yourself and see that, oh look, MACD is going over the signal line. You buy it at that point. And similarly here, you sell it at this point. And like that, you keep going through it. But you can maybe notice when it's not doing so well is like right here. So let's zoom into this little pocket. So you can see right here, man, these differences are so many. I can even see them right here. But yeah, if you can see, they're really close, but the MACD line just goes over the signal line right here, and it generates a buy signal, and then it sells it on at a loss. So you buy it at 685 and you sell it at 653. So you lose money. And you might be wondering, why is that happening? It shouldn't be happening, right? But the reason that this is happening is because this is a very horizontal part of the graph, and there can be a lot of false signals generated. And when they do generate, you're going to just lose a lot of money. So that's kind of the reason why you don't use this trading strategy in real life. And this is a simple example of it. And you can see with the histogram, like this histogram has like much higher value here, but here it's just like it's close to the zero line, but it's still generating buy and sell orders right here, which are not the best orders, but as you can see, they're still creating them. And you lose a bunch of money there too. But when there's dramatic actions in the market, like you can see right here, like there's crazy amount of increase, this algorithm works really well in these dramatic changes. So this one bought it at October 12th and sold it at November 10th, and you made a lot of money off that too, because there was a dramatic increase. Now let's change the timeline a little bit and see the graph of it change. So let's go to 2011, since Tesla did exist then, even though it's a very young company. And when you run it, it's just going to create a new tab with the HTML files that you need. And you can see a billion trades that it takes place, but they're not the best trades. So let's look at this very horizontal part of it, right? Let's isolate for the horizontal part of the graph. So you go from 2011 to 2013, sometime in 2013, doesn't matter, right? And it's a very quick change for this testing part of it. So 2013, 1, right? Let's run the algorithm and let's see how well it does. And you can see it returns a 27% return, and it's an even worse win rate than before, because as you can see, this was a very horizontal part of the market, and it might not look like that right now, right here, but if you look at the prices, they're going for $5 to just like 7.5. So it's not a lot of changes, right? So you can see it doesn't perform very well in the market. You actually lose a bit of money, even though the average gain, like what do you call it? The highest gain was 27%, 1.7%, and things like that. If that makes sense to you guys. So I think this is a good demonstration of where you can use this, and you can literally put it in any ticker you want. Any ticker you guys want to see and how this performs on. And any timeline. I'm just gonna put it on Amazon for the hell of it, and let's see. Yeah, so Amazon in the same time frame average return of 1.6%, and they won 45% of the trades, but as you can see, it's still under 50%. So you kind of just got lucky with the 1.6%. Peloton. All right, let's try that. I don't even know what stock that is. Oh, Peloton. Did it exist back then? No, it did not. Okay, so let's do it from 2021 to now. Man, it's been falling though from 2020. But yeah, let's change the time frame for that. So 2020. Wait time dot now. There you go. You get that now time. And this is a kind of an opposite type of graph, so I'm quite curious how this turned out. Yeah, you lost 12% of your money, or whatever you traded in. So you placed 9 trades, win rate of 22%, which is very, very bad. And yeah, the most return you got out of any trade was 13.45%, but it went very badly for you. So another demonstration of why you shouldn't just use MACD, but you can maybe implement RSI on your own into this algorithm, and you're going to be good from that. So with this, you can kind of see what I was trying to get you guys to make, and this is kind of the basic structure of what I kind of wanted you guys to see. And you can see right here the overview of what I just made in very simple terms. And a simplistic indicator-based trading strategy is not the best. In real use cases, you would be taking in data from statistics of correlations and things like that. But all of that can obviously now be covered in this small workshop setting. But if you guys are curious about any of this, I'm always open to help. And I think that's it from me. Do you guys have any questions? Thank you for listening. Ooh, I like this question. Wait, let me see. Wouldn't you have to specify some sort of monetary amount of the program has to use, or would you just let the buy orders fail if you didn't have enough? Yeah, so in the real use case, you would have to specify like a certain amount of money that you don't want to go over, but most like brokerages that you would be using this with, they would just like go on margin at that point. So like if you create a variable, it's gonna keep it. Any other trading strategies you suggest to explore? Yeah, so you can probably just go on YouTube and see this channel called Data Trader, and he uses a lot of very similar trading strategies with indicators on the Forex market. So you can go look at those, and a very good idea if you want to follow this momentum strategy that I'm just putting it out there. You can use like the RSI, the parabolic SAR. That's another good one that you can use. There's a bunch of indicators that you can play around with. And if you just look at this algorithm right, not there, sorry. If you just look at this right here, if you just create if you create like a for loop going through like an array of a bunch of different indicators for stocks like Peloton, Palantir, I don't know, whatever you want, GameStop, and things like that, then you can just see how it performs in different stocks in different sectors of the market, and just learn a lot about your trading strategy in just a very simple manner. So there's a lot of improvement you can make here, and just have fun and learn as much as you want. Any other questions? This is a topic I really enjoy, so I would love to talk to any of you guys if you want. I can link my LinkedIn if you guys want to talk to me there or something. Yep, there you go. This is my LinkedIn. I'll send it to Yeah, so one like platform I can suggest to you guys, if you want to trade is try to use maybe Alpaca. That's something I've been looking into previously. It's pretty nice if you want to learn about this. So it's commission free and everything, and you can play around with the API. It's much more complex. Obviously, you need to know like Node.js or something like that, or even Python works, but this is a bit more complicated. But if you want to see real examples of it, like trading in a live market, try this out. But yeah, pretty fun stuff. All right. I think that's it for me.
Will it make us rich?
This one, no. Other strategies, yes, but I would not tell you guys. I'm just kidding.
Is cryptocurrency a good investment?
Cryptocurrency, yes. It runs 24 hours, so very good for algorithmic trading or
What,
testing it out.
what if Elon Musk tweets against the cryptocurrency? What happens then?
You need to make a bot just so the second he tweets um, about your cryptocurrency, you need to start massively selling it. He is the biggest wild card in the crypto market. That's a pretty fun side project if you want to make.
Yes. Insider trading, of course.
That's actually a very realistic strategy to do social sentiment on tweets and even subreddits like GameStop, not GameStop, Wall Street bets and stuff. Because real traders, real algorithmic traders do a lot of that social sentiment type of stuff. Yep.
All right, so I think we can wrap it up. Or
Yep.
do you have more questions? All right, thank you everybody for attending this workshop hosted by Google Developer Student Club, McMaster University. If you have any further questions about the workshop, or if you want to just speak to Bilal, he's going to be on our Discord, and I have posted the link to that just now in the chat. Make sure to join if you want to keep up to date with our events. We'll be hosting quite a few more throughout the rest of the semester and the rest of the year. Yeah, thank you for coming out, and have a great night.